Yeah. First, what we were discussing yesterday? Routing starting. So yesterday we completed what exactly the routing is, and then we are saying that some types of routing. Okay, what are those types? Mm-hmm. Mm-hmm. Let him. Yes. Okay. So what methods we use in static? Mm-hmm. Okay.
Manual will provide IP routes for them and next hop using next hop and exit interface.
Okay. One more. Yes, Manoli.
Sir, we lesson the IP same answer also.
Mm-hmm.
Using exit interface and next hop methods.
Mm-hmm.
The third one. So,
It's not visible. Not visible.
floating.
Floating static. Okay. Yeah, sure. What is static routing?
Static routing is a routing which we manually provide the route
Hmm.
in the network.
Why we manually provide the routes?
Static routing, its AD value is the one, so it will be secure. It will be very secure.
Okay. No, I didn't get your answer, proper answer. Yes.
You can only provide the packet, but for the security purpose, and you should provide the packet.
My question is why we inject or add the routes?
Perfect.
The best path. Okay.
Manually add IPs in small network, it is useful. But in the large network, we manually
Hmm.
just for the security and best path to use static. So when we have multiple paths to choose the best one.
In yesterday's scenario, did we have multiple paths? Then
Complexity is less.
Kritik.
Static for security purposes.
Uh-huh.
When we assign manually IP address, that time security compared to the we need to understand which IP we have added administrator know that. Static static is manually assigning because the purpose of security and
Okay, leave this security static and all. I just want other answer. That's why I'm waiting, right? And that's why I'm asking to everyone. Next. Uh-huh.
that so we can easily assign the IPs. That's why we added the view. I don't know.
Yes, Karthik.
is secured and only administration can assign the IP, then he will know what he can configure it.
What did I say yesterday? Like, why we add those routes?
Or transfer the data packet from one network to another.
Because to make the communication between the network, different network, and obviously which network we add, which are not directly connected to the router. So that's what I was expecting. Okay, why we add and which routes we add? Which routes which are not directly connected to the router. And if you want to make them, to communicate with each other, then only you will add the route, okay, into the routing table of the router. Understood? In that first method we used in a static one, that is the next hop. That is, next hop IP address will give. That means just to forward all the data traffic, if you are getting this IP address traffic, okay. And exit interface means what? Self exit interface, where it is connected to the next router. So that exit interface you will be giving there. Understood? So these are the two methods we are seeing, and one more method we are seeing. The type of the routing, that is default routing. So in which case we use this default routing? Online, can I have any answer why we use and when we use this default routing?
A stub router or in the end devices.
So we exactly configure it on the stub router, or you can say edge router, where it is connected to the ISP or the internet. Okay, where the destination IPs will be unknown. So in that case, we use this default routing. So what is default routing? What is the syntax which we have? Vaishnav? Vaishnav, are you there? Mr. Pradesh, can you just tell me like how we configure this default routing?
Yeah, I don't recall the command. Actually, I didn't go through that video.
Okay,
Sorry for that.
it's okay. How we configure that one? Again, we have our what do you call word, that is IP routing. This is a command that will enable the static routing. Okay, statically we are giving the route, and if it comes to default routing, we give it as what? Any IP address with any subnet mask. What is any IP address means? 0.0.0.0. It's nothing but what? It is a network address for all the 4.3 billion IP addresses of the version 4. Next, again, subnet mask, any subnet mask. Okay, so that will be forwarded to this next hop IP address. Okay, so this is how we configure the default routing. So next, one more we have in the static one, that is called floating static. Okay, so what exactly the floating static is? Again, it is related to the redundancy. Okay, let's say this is my router 1, router 2, router 3. Okay, these are the 3 routers I have. Yes. So if I don't connect this routing here, this path, so from router 1 to router 2, there is only one path, and from router 1 to router 3, there is also only one path. If you want to have one redundancy, then what you will do? We'll just connect these two, router 1 and router 2. Okay, in this case, router 1 can reach this router 3 directly and via router 2 also. Okay, so how to configure, how to say this router that if this link fails, then you have to go via this. How to configure that one? How to say this to the router? So that is called as what? Floating static. You are giving, for one network, you are giving two paths. Okay, one is directly and second is what? Via router 2. Okay. Can see here. This is a technique used to configure the backup route in the network, and it involves setting a static route with a higher administrative distance value than the primary one. So it is totally, related to the AD value. AD value. As I already know that router prefers what? Always it prefers the lesser AD value as the best path to reach the destination. Am I right? So if I'm having, so let's suppose like I'm configuring this, what do you call path as a primary statically. Okay. And what AD value will get here? Obviously 1. Okay. Then we have to say this router that here also if you are configuring this, what do you call static routing. Okay. You just need to increase the AD value there. If it is 1, you can make it 2. That means this is the highest one now. Whatever the currently we are having, that is 1, which is next highest, sorry, next least. 2, obviously it will go for the next backup route. Okay, that we have to give it here when you're configuring. Okay, so that's what I said. It involves setting up a static route with a higher administrative distance value than the primary. Currently it is having 1 here. I'm going to make it as a 2. Okay, so again it depends on like if you are using the dynamic one, again what is the AD value of RIP protocol? I said it right. AD value of RIP protocol 120. If you are using RIP protocol and if you are giving secondary path, okay, then you will make it as what? 121. So that means what? It is going to go for the secondary path. What is the OSPF? What's the OSPF? AD value. Sorry? 110. Okay, then we have to give it at least 111. 1 higher than the current or primary AD value. Okay, so that will become what? Backup route. Yes. So the route will be only be used when the primary route becomes unavailable. So when this will be used, and you can't see this route, you can't see this higher AD value route into the routing table. When it comes to into the routing table, whenever the primary route goes off, then only it will be showed up in the routing table. Till then, it will not be there. Okay. So some key concepts of this floating static. First one is like you have to configure the primary and backup routes. So what are these two? Primary route is nothing but what? It is usually has a lower administrative distance. If it is dynamically learned route via OSPF or EIGRP, then it may be 110 or 90. Okay. This is what dynamically learned. If you have done it with a statically, then it will go for 1. Okay. So what is the backup route? It is also called as what? Floating static route. It has a higher administrative distance than the primary route, ensuring that it is only used if the router, that is primary router, fails. Okay. By having, which is having the higher administrative value than the primary route. Okay, don't worry, I'll show you later. I can see that you are not able to understand it. Next, we have some AD values here. Okay, what exactly the AD value? As I said yesterday, AD, what is AD? Administrative distance. What is that? Trustworthiness of what? Trustworthiness of the route or routing information provided by the routers. So least the AD value, that is the best path. Okay. So directly connected, as I said you, the AD value is 0, and static route which is having 1. Okay. It is default for regular static routes, and OSPF I said 110, EIGRP 90, and RIP we have 120. So different protocols we have some different AD values. Okay. So where we use this one, it provides a redundancy in the case of link or routing protocol failures and commonly used in a conjunction with a dynamic routing protocols or a static route. You can use it in a redundancy protocols. Okay. And how exactly this static route works? So static route is configured with a higher AD using the distance parameter. So how exactly you configure this one? You can see here, there's a example. Okay. So IP route, you're going to use the same thing. Okay. And you are going to give the destination, network ID, and then subnet mask, and then next hop you are going to give. And after that, whatever the value you can say, that is called as what? AD value. Okay. Which should be higher than what? The primary route. Okay. So the router prefers the route with the lowest AD value in the routing table. And then if the primary route removed, that is due to because of any kind of a link failure or something, then the floating static route with a higher AD is installed into the routing table as a fallback. Till then, it will not be there in the routing table. Okay, understood? Okay, in between these two, I'm going to give 192.168.1.0 slash value 24. And here I'll give 192.168.2.0 the slash value 24. And here I'm going to give 192.168.3.0 the slash value 24 network. Okay, so these are the three network I'm going to use here. Then obviously here it will be dot 2. Okay, and here it is dot 1. Dot 1, dot 2. I hope you understood what is this dot 1 and dot 2. You did? Okay, now let's assign the IP addresses. Okay, so gigabyte Ethernet 0/0. What IP address is there? 102, 255.255.255.0. And then no share exit interface gigabyte Ethernet 0/1. Here the IP address will be 192.168.2.2. Okay, with 255.255.255.0, and then just say no share exit from the interface. Done. So I've assigned the IP address to the first router. Let's go to the second one. Enable conflict the interface gigabit ethernet 0/0, and here the IP address is what? 192.168.1.1 with 255.255.255.0, and just say no shares down and exit. Interface gigabit ethernet 0/1. Here the IP address will be like 192.168.3.1 and with 255.255.255.0. Just say no shares and exit. Okay. So here I assigned the IP addresses on second router as well. Let's go to the third router. No. Enable config T interface gigabit ethernet 0/0, and the IP address will be like 192.168.3.2 with the 255. No shut and exit. Interface gigabit ethernet 0/1, and here the IP address will be 192.168.2.1 array. Yeah, 2.1 with 255.255.255.0, and let's say no shut exit. Okay. So now tell me, on the router 0, what routes will be there? What route will be there? Two directly connected routes. One is 1.0 network and second is a 2.0 network. And which one I have to add here? 3.0 network. And on router 1, currently it is having 1.0 and 3.0. I have to add the opposite one, 2.0. And here on this router 3, I have to add 1.0 because it is having two directly connected routes, 2.0 and 3.0. So let's try to do that one. Okay, so again your IP route. So 192.168.3.0 with 255.255.255.0. In this case, I'm gonna give this interface. I mean the next hop as what? This one. What is that? 192.168.1.1. Okay. So here I'm not going to give any kind of AD value. This is my primary route. Okay. Next, enter one more route I'm gonna use. That is same but via this side. That is 2.1 with a higher value. The current one, that is a 10. Currently this having 10. You can use any other. Okay, we are not using any kind of a dynamic one, so you can go for any number. That is I'm gonna use here 10. Okay, just say enter. Done. So I have added the routes here. Yes, if I say do show IP route, which route it is showing? Which route it is showing? Via 1.1. Why? Why it is showing 1.1? Because it is having the AD value as 1. Can you see 10 here in the routing table? No, it comes in the picture only when this this interface or link goes down. Okay. So let's go to second router and do the routing here. So IP route 192.168.2.0 with the 255.255.255.0, and via directly I'm going to go via this router 0. Okay, that will be primary. So 192.168.1.2. Okay, this will be primary. Yes, this one, this interface 1.2 it is. Okay, and next route. So I'm gonna go via 3.2. okay, with a higher ID value, that is 10. Okay, and enters. Clear? If you see the IP routing table, you can able to see here. Static, here it is. 2.0, which one it is having? Again, the route which is having ID value as 1. Okay, so let's go to router 2. Sorry, yeah, router 2, and then just add the route. IP route, which one I have to add? 192.168.1.0, and then 255.255.0, and this time the primary route I'm going to keep, that is this 192.168.2.2. Okay, 192.168.2.2, that will be the primary, yes, and the secondary will be like 3.1 with the higher ID value than the primary, that is I'm going to give it a 10. Then just say enter. If you want to see, do show IP route. You can able to see here which route it is showing, 2.2. Clear? Now let's check. Which path it is taking. First, let us ping. So ping 192.168.1.1 or else 1.2. Alright. Do ping 192.168.1.1. Pinging. Okay. 1.2 is also pinging. Let us see like which path it is taking now. So for that we use a command called trace route. Okay, it will give you the path, which path it is taking to reach the destination. Okay, currently I'm on this router 3 and I want to reach this 192.168.1.2. Okay, so 192.168.1.2. Which path it is taking? It is going 2.2 and it is reaching there. That is nothing but this router. Okay, so let's do one thing. Let's make this interface as down. So interface gigabit Ethernet 0/1, just make it as a shutdown. Okay, let's check it again. Yeah, which path it is taking? 1.2. That is nothing but this one. Okay, so if you check the routing table of this one now, QIP route, what path it is showing? 3.1, which is having the ID value as 10. This is a secondary path. It comes in the routing table only when the primary is down. Till then, it will be stored in a memory of this router. Okay, understood, everyone? And if I say again no shutdown, it will come up and again that will go for what? The primary route. If you want to check, you can check here. Yes, it went into 2.2. Understood? This is what the floating static is. Okay, if you want to check with any other, you can do that. And this route 192.168.3.2. Okay, it is going via 1.1 and then 3.2, reaching here. Okay, let's suppose like this 1.1 goes down. interface gigabit Ethernet 0/1 or 0. Just make it as a shutdown. Okay. Let's check it now. Where it is going? 2.1 directly. Okay. Understood. So this is how to get the redundancy with the help of this floating static. Any doubt? Any doubt, everyone? Online? Online? Mr. Narendra, Pradesh, Vaishnav.
I'm okay.
Yes, sir.
Okay.
Yeah, I'm fine. I'm fine. Thank you.
Yeah, this was about the floating static. Okay. So now we completed the static routing and then default routing. Now it's time for dynamic routing. Okay. So how many types I said in dynamic routing? 3, sure. What are those? 4, who is that? We have, this is how the tree of the dynamic routing, guys. Okay. So in this we have 2 types major. Okay. One is IGP, okay, which will route the network or traffic within, keep it in mind, within same AS. Okay. We'll come to know what is this AS in EIGRP. Don't worry. AS is nothing but autonomous system number. What is this? Autonomous system number. Okay. So IGP will help us to route the traffic within the same AS, and EGP, it is nothing but what? Exterior gateway protocol. It is between the ASs, between different autonomous system number. Okay. So this is what these major 2 types we have in the dynamic. In that, in the IGP, again we have some types. How many? How many? 3 we have. First one. Distance vector protocol. Second one is link state protocol. Third one is hybrid protocol. Done. And in again distance vector protocol we have 2 types. First one, rest in peace. Second, IGRP. It's not rest in peace. Routing information protocol. And in the link state protocol, again we have 2 types. One is OSPF. OSPF stands for open shortest path first. And second one is ISIS, intermediate system to intermediate system. Okay. And in hybrid we have one EIGRP, which is nothing but enhanced interior gateway routing protocol. Okay. This is IGRP, interior gateway routing protocol, EIGRP, Enhanced Interior Gateway Routing Protocol. Okay, and in EGP we have only one type, that is a path vector. It is a path vector protocol, and in that we have only one, that is BGP. Very important. Okay, because we use this into the ISP. Okay, I mean, which is configured on the internet routers, ISP routers. Yes. Okay, so this is how the tree looks like of this dynamic routing. Okay, so what is exactly the dynamic routing? Yes. Is somebody taking this one? Written? Okay. Yes. What is dynamic routing? Yeah, what is this? Dynamic routing, it makes automatic adjustment of the routes according to the current state of the route in the routing table. Okay. In static routing, what you are seeing? Manually, the administrator used to add the routes which are not there in the routing table. Okay, which are not directly connected to the router. Here, what happens? You just advertise your network to everyone. In dynamic routing, what you will do? You will just advertise your network to everyone. So these are my network. Okay, please make a note in your routing table. Just save it in your routing table. Okay, again for that it will be having some different algorithms and different methods to find the best path. It is if it is having multiple paths. Okay, so that's a secondary. So dynamic routing uses the protocols to discover network destination and the route to reach it. Okay, just like RIP and OSPF are the best example for dynamic routing protocols. Yes. Yeah, you can take any other protocols also, not only RIP and OSPF. Yes, you can take EIGRP, you can take BGP, and yeah, obviously ISP, ISIS and IGRP, they are not in being used now. Okay. So automatic adjustment will be made to reach the network destination if one router goes down. Again, the same thing I said you, here automatically every route will be learned. Okay, nobody is going to add it into the router. So what they will do? Just they will advertise their network, their routes to the other routes. Okay, I mean routers. So based on that, they are going to learn the IP addresses. Okay, based on that, again, some algorithms will be working on those protocols or routers. Okay, based on that, it is going to find the best path. Clear? So what are these features like of this dynamic protocols? The router should have same dynamic protocol running in order to exchange the routes. I mean, if you have two routers, you can configure same protocols on these two. Okay, that will be easy to exchange the routes, okay, and to find the best path. And when a router finds a change in the topology, then the router advertises it to the all other routers. It is very good feature in dynamic protocols, I can say. What is this? What you are seeing in the static one? In the static, if the topology changes, okay, the administrator himself has to go to the router and he has to configure that topology change. But what happens in dynamic protocols? Router itself will let other routers know that yes, this is what the topology change happened in our network. Okay, this is what the network I have got. It's a new network. You just keep it in your routing table. Okay, this will be helpful to reach that network in future. Understood? So that's what each and every router, they will advertise all the topology change networks to all the routers which are present in the topology. Okay. So some advantages of this dynamic routing protocol. Yes, it is easy to configure. Okay. It is not like you just need to find the exit interface or a next hop. Okay. And you have to find the network address of that one. Again, you have to say IP route and type it. No. Okay. You just need to give router RIP, router OSPF, router EIGRP. That's it. Okay. And then you have to advertise your network. That is done. Yes. So after advertising, every router will exchange their routing tables with each other. Yes. Become neighbors, and then the dynamic routing will be start working. Okay. So it is more effective at selecting the best path to destination remote network and also for discovering the remote network. So in which scenario we can use this? In which scenario we can use this one? Dynamic one? In a large network or a complex network, we can say. But we can't use this static routing in the large network because again, we have to add all those routers. It's kind of a hectic work for what? The network administrator. Okay. And the same, this is not secure. Why it is not secure? Because if the attacker comes with his own network or something, okay, he can easily get into the network by configuring his router or his device also into the same dynamic routing. Okay, what we have seen in the static one? In the static, even the attacker comes, okay, so he don't know what kind of network we have, what kind of routes we have in the static routing. But here, if he runs the dynamic protocols, okay, he can easily get into the network. Yes, if it is known. Then disadvantage of this dynamic one, like it consumes some more bandwidth for communicating with each other, like other neighbors. So what you are saying in the static one, there the bandwidth will be, and even the CPU processor will be less used because they are just giving the or injecting the routes manually. But here routers will learn it automatically. So that's the reason the bandwidth will be consumed more here. Okay, and even the processor speed will be high. Okay, and it is less secure than the static routing, as already said. Yes. Okay. So you already know that. What is administrative distance value? You want me to repeat it again? No, right? What is the administrative distance value? Okay, I'll just read it for you. It is a value used by the routers to determine the trustworthiness of that route source. Okay, it measures the preference given to the routers learned from different routing protocols or sources. And routers always go for what? lower AD value. Lower the AD value, the more trustworthy the route is. Understood? And these are some different AD values we have. So what is the purpose of this one? AD value helps the router to decide which route to install into the routing table when the multiple routes to the same destination are learned from different sources. Okay, so let's suppose like we have some multiple paths to reach the destination. Okay, so all these routers will give you some different paths. Yes, and here we have added static routing. Here you are using RIP protocol, and here you are using OSPF. So in this case, what the router will do, it will take this as only the best path. It is going to take this as the best path to reach the destination device. Why? Because AD value is 1 here, and here it is 120, and here it is a 90. So that's the reason it will go for what? Lowest AD value. Yes. So this will be the best path to reach the destination. So that's the reason we use this AD value. Clear? So these are the different AD values for different what do you call routing methods. First one is directly connected, that is 0, it is mostly preferred. Second one is static one, that is 1. EHRP internal, that is 90. OSPF 110, ISIS 115, RIP 120, EHRP external 170, and unknown, that will go for 255, and it is totally not preferred. Okay. Now we'll see the first type of the dynamic. What is that? IGP, Interior Gateway Protocol. In that we have three types. First one is a distance, second one is a link state, and third one is a hybrid. Now we'll see, today we'll see the distance vector protocol. Okay, what is this distance vector protocol? Here the router share information about directly connected network and the distance, okay, to the other network. Yes. So this is kind of what? Totally based on the distance. What do you mean by distance and vector? No. What do you mean by distance and vector? Meaning. Leave the distance. What do you mean by vector? Direction. Okay. So in this one, distance vector protocol, it will give you both. What is the direction and how much the hop counts are there. Okay. So distance vector protocols always prefers the hop counts. So based on the hop count only, it is going to forward the data, and it always prefers the least hop counts. Wherever it is getting the least hop count, it will be maintaining it as a best routing path. Okay. So here, what happens in the distance vector protocol? They know only their neighbors. Let's suppose this is my R1, this is my R2 and R3. This R1 know only R2 and R3, no one else. Let's suppose like if you have connected some more routers to this, router 2 and router 3, they don't know who is this. Okay, until this router 2 and router 3, let this R1 know. Okay, that is the reason it says that it just have the information about directly connected networks. Directly connected networks. Okay, again it is going to give the distance, that is nothing but what? Hop counts to the other network. Understood? So it will give the periodic update to the neighbors with a routing table. So this is one of the biggest disadvantage of this distance vector protocol. What is that? It will give the periodic updates. Periodic means what? So we are talking here. Okay. So after every 30 seconds, I'm going to say hello him. Nothing is there. Okay. No change. I know him very well. Every time. Hi, hello. My name is Arun. Hello, my name is Arun. For every 30 second or 60 second, this will be what? Giving the information or saying the hello to the neighbors. This is called as what? Periodic updates. So even though there is no any change in the routing table or the topology, every router they will exchange the routing table after every 60 seconds. Okay. In RIP it is 30 seconds. For every after 30 seconds, they will exchange the routing information with each other. Okay, so that's what the biggest disadvantage of having this distance vector protocols. Okay, and it uses one algorithm called Bellman-Ford. It is one algorithm that is configured with this one distance vector protocol just to find the best path. Okay, so different dynamic protocols, they use some different algorithms that we'll discuss it later. Next, some key characteristics of this distance vector, like routers rely on the neighbors for network knowledge. So that is the reason we call it as what? Routing by rumor. I mean, whatever the router 2 is sending some information about any network, this router 1 is going to maintain that one. Okay, it is by what? Just routing, it's doing the routing by rumor. What the router 2 says, router 3 says, I'm going to have it because they are my trusted neighbors. This is what happens in the distance vector protocol. Okay. So here the slower convergence will take place, like risk of loops during the changes. Like if any kind of topology changes here, it will be very, reaching this router 1 very slowly. Why? Because this is a distance vector protocol. Yes, which will be giving or updating. It will be giving or updating to the neighbors very slow process. Okay, if you see it in the link state protocol, it will send it at the same time. But here what happens? This router 2, so let's suppose like this is router 5. One more router is connected to this one. So first it has to send it to this one. Router 5 will send it to router 2 and this router, and then router 2 will send to router 1. So this is kind of what? Slower process. What happens in the link state process? At the same time, it will be broadcasting the same message to everyone. That is what the faster convergence will be taking place in the link state protocol. Okay. So in here we have some two protocols. One is what? RIP, routing information protocol, and second one is the IGRP, interior gateway routing protocol. Okay, so these are the two protocols we can have in the distance vector protocols. Yes. So now we'll see the first one, that is RIP protocol. So before that, we'll just check how router is going to select the best path. What is the election process we have? Okay, first one, it look for what? Longest prefix value. That means looks for the highest CIDR value. Let's suppose we have this router, okay, which is connected to 3 routers again. Okay, and here I'm having 10.1.1.0 network with the slash value 28, 20.1.1.1, 0 with a slash value 26, and here I'm having 30.1.1.0 with a slash value 20. So what it will do? It look for what? The highest CIDR value. Okay. Next, what if all the CIDR value are same? This is also 28 and this is also 28. So in that case, what it will do? It will go for what? Lowest AD value. Okay. So let's suppose if I configured with the RIP here, OSPF, here GRP. Tell me first, which will be the best route? Yes. RIP is having 120, OSPF is having 110, EIGRP is having. So this will be the best path to reach the destination. So in case you configured all of them with a RIP, consider you configured all of them, you configured with the RIP protocol. In that case, what it will do? It look for the number of hop counts. What is number of hop counts? Let's suppose like if you're connected some more routers here. This is my destination device, and here it is having only one, and here Okay, how many hop counts here we have on the first part? 1, 2, 3, 4. 4 hop counts. And here 1, 2 part. And here 1, 2, 3, 4. So which one it will take? It will take the second one as a best part, because here it is having only less number of hop counts. Okay, one more thing, even though you are having the highest bandwidth here, the RIP always prefer for what? Least hop counts. Okay, let's suppose here we have 10 gig links, 10 gig, 10 gig, 10 gig. Here we have fast Ethernet, that means 100 Mbps, and here also we have 1 gig. But still it look for what? Least hop count. This is a metric of the RIP protocol. What I said? Metric. Metric is nothing but it is a parameter which is used to find the best path. Clear? So here how many what is the link we have? Bandwidth. Total 40 Gbps. Okay, but still it will go for what? This 200 Mbps. Clear? Why? What it says? It see what? Hop counts. That is also least. You can see here. Metric used is least hop count. Okay. And the third, last one is what? Load balancing will happen. If the same metrics are used, then it go for the load balancing. What is load balancing? Let's say all are having the RIP protocol, all are having what same hop counts and all. Okay. So in that case, what it will do? It will do the load balancing. It is going to share the same data through every links here. Okay. So this is how the routers, they will find the best path to reach the destination. Am I clear? Next we have the RIP protocol. RIP, it's a distance vector protocol. It's nothing but routing information protocol. Okay, it's a part of what? Distance vector routing protocol. Yes, and it's a layer 7 protocol. That means which generates the data at layer 7, but it works at the layer 3. Okay, and it is a UDP based protocol. What it uses? It's not a TCP, it's a UDP based protocol. And what is the port number of this RIP protocol? It is a 520. Port number. Where we use the port number? Where we use the port number? In which layer? Which layer? Port numbers. Data link layer. Good. Transport layer. Okay. We use the port number at the transport layer. Okay. So what protocol is this? Is just to find that one, we use this port numbers. Yes. I said, I hope you remember that well-known port numbers, random port numbers. Remember? Which are the well-known port number? What is the range? Hmm? The total is 65,000. That is correct. 021023. This is a well-known port numbers, and remaining 10242 65,535. This is what? Random port numbers. Okay. And it comes under which range? Well-known port numbers. Okay. And the default AD value of this what? 120. Yes, what is the default value of the, default AD value of this RIP protocol? 120. Yes, it is changeable. Yes. And metric used by this RIP is what? Hop count. That is also least. Wherever it will find the least hop count, that will be finding it as a best path. Okay. And maximum hop counts this RIP can cover, that is just 15. That means it can jump only 15 routers, 15 times. That means 16 router. It is not going to send its routing table to the 17th router. No, because it is having the maximum hop count as what? 15. Okay. Yeah, it uses a algorithm called Bellman because it is a part of this distance vector routing protocol. Okay. Next, we have some versions in RIP. Okay. So somebody says like we have only two versions like RIP version 1 and RIP version 2. Okay. But there is one more that is called as what? Default version. Okay. What is the default version? You can see here, first one, it can send the information to version 1 only, but it can receive the information from both. That is version 1 and version 2 routers of RIP. Okay. It uses all properties of the version 1. So what is the version 1 properties? You can see here. So version 1, it can send the information to version 1 and default, but it can receive from only version 1. Okay. So it supports classful routing. What is classful routing? Which belongs to the same classes and which does not support VLSM and CIDR. Okay. And here we don't have any kind of authentication in version 1 and even in the default version. Okay. So this is nothing but default version and the version 1. And second version, that is it can send and receive the information only from the version 2 kind of routers. Yes, it can send it to default version also, but it can receive only from the version 2. Okay. And it supports classless routing. That means it supports obviously VLSM and the CIDR values. And here we can have the authentication on every port of the RIP protocol. Okay, of that router, if you are configured. Yes. So in version 1, it doesn't have any kind of authentication. And in version 2, it uses a authentication. I guess it is MD5, I guess. Yes. It uses this authentication. Yes. And I was talking about some of the timers here. What is the timer I said? First one is a hello timer, that is of 30 seconds. So here in RIP protocol, every router, they will say hello to each other every after 30 seconds. Even though there is no any changes in the topology, they will send its own routing table to the neighbors. Okay. And second one, hold timer, that is of 180 seconds. Hold timer means what? Let's suppose one neighbor is down. One neighbor is down and that is not replying for the hello message. So in that case, what the router 1 will do? It will wait for 180 seconds. Okay, before removing this routing table of this router 2, it will wait for next 180 seconds. Okay, that is called as what? Hold timer. Okay, so during that, it will be not having the router 2. Okay, this is my router 1, this is my router 2. Okay, let's suppose this link is down. That means it is not replying for the hello messages. Yes, and it will wait for 180 seconds. And during that, if this router 1 is connected to one more router, yes, so it will be sharing this router 2's information to router 3, but it will not keep it. Okay, it will be there in router 3 of router 2's information, router 2's routing table. Okay, so that will be waiting again. This router 3 will also be waiting again up to 240 seconds just to flush that routing information of that router 2. Understood? So these are the 4 timers we have here. First one is what? Hello timer, that is of 30 seconds. Next is hold timer, that is of 180 seconds. Second is the invalid timer. So during this invalid timer, this router 3 will be having the information of this router 2, but router 1 will not be having it. Okay, and after 240 seconds, both the routers, they are going to flush out the router 2's information from their routing table. This is called as what? Flush timer in the routing table. Understood? So let's go and do it on the CPT. Okay, today I'm going to use the same. Okay, because you already know that how to configure it, right? Yes. I think currently I'm having some information, some routing on this one. Let us check that. Enable show run configuration. Yeah, OSPF I have. Okay, I just removed the configuration which I had before. Okay, So let's this side. Okay, great. So you want me to explain whatever the configuration I've done here? I mean, just the IP addressing. You can see here if you want. This is the network I have given 1.1. Okay. On this one, I mean, like here I have given the default gateway as what? 192.168.1.10. And here I have given 2.10. And here I have given 3.10. Okay. And in between these two, I have used the IP address like 4.0 and 5.0. Yes. So here I've used dot 1, and here I've used dot 2, and here 1, 2. Okay, this was the configuration, very simple. Yes. Now let's go to the configuration of the router with the help of rest in peace. Let's go to the CLI of the router, and then it's very simple to configure this RIP. Okay, how to do that? Here the word comes, that is a router. Okay, if I say question mark here, it will be giving you 4 options. What are those? BGP, EIGRP, OSPF, and a RIP. Okay, this Cisco packet trace support only these 4. Can you see any other like IGRP, ISIs? No, no, right? So it supports only 4 protocols. First one is what? It's a BGP, border gateway protocol. Second one, enhanced interior gateway routing protocol, open shorted path first, and the routing information protocol. So today I'm going to use last one, that is RIP protocol. If I say question mark, is there any? No, then that's it. Just say enter. Now we are into sub configuration mode of that router RIP. Okay. Here, if I say question mark again, it says that. So forget about all this. Just see here. Says that enable routing on IP network. That means here you have to advertise directly connected routes. Okay. What are the directly connected routes are there? What are the directly connected routes are there to this router 1? 1.0 and a 4.0. You have to say network 192.168.1.0, and that is it. And second one 4.0. If I say question mark, nothing is there. That is nothing but done. This is it. Yes. So and it here, and if you say show IP route, there it goes. It shows only directly connected routes. What are those? One is 1.0 and second is a 4.0. And the same routes we have advertised it to every other routers. Okay. To receive that one, all these routers has to be again configured with the RIP. Okay. So open this one and just say router RIP and network. How many? First 4.0 and then 2.0 and then 5.0. So these are the 3 routes. Yes. To end it here. Can you see something here? What is this R? R means what? RIP. Okay. So this learned this 1.0 network via this help of this RIP protocol. What is the AD value? 120. And what is this I said? Metric value. So how many hop counts it has to take to reach the 1.0 network? Only one, because it is directly connected to this one. Once it jumps to this, okay, it will be reaching the 1.0 network. Okay. Now according to this, if I configure a routing rip on this one, how many hop counts the router 3 needs to reach the 1.0 network? 2 hops, okay, 1 and 2. It will be reaching the 1.0 network, okay. So let's go to the third one. So router rip and just say network 192.168.5.0 and second one is what? 3.0. That is it. Okay. Exit. So do show IP route. What it says? First one. 192.168.1.0 with a slash value 24. Okay. This I learned. This route I learned with the help of this RIP protocol. Okay. And what is the AD value of that one? Because of this 120, it will understand that this is a RIP protocol. And how many hop counts I have here? What is the metric value? To reach this 1.0 network, I have to jump twice via 5.1. What is this 5.1? What is 5.1? It is the next hop. Okay, you can see here. What I have given here, 5.1. So it is what? Next hop, and even it will give you exit interface as well. So it is all happening automatically. Okay, did I add any? No. I just advertise my network to everyone. Understood? So second one also, it is learning the same, like 2.0 network. What is the AD value? 120 again. What is hop count? 1. Because it has to just jump once. Okay, it is going to reach the second router, and on the second router only it is connected with the 2.0 network. Why again? 5.1. Why? Because it is having only one path, 5.1, with the same exit interface, that is 0/0. And one more route it learned, that is 4.0. Again, it has to jump only once because that is also directly connected to this router 2. Okay. Here also we have next hop as what? 5.1 and exit interface as 0.0. That's it. Okay. So let us check the connectivity. Just say ping 192.168.3.1. Okay. Pinging. The first packet gifted to up and remaining are getting the reply. Okay. Even if you check with the second, that is 2.1, that will be getting the reply. Done. Clear? Now, we'll discuss about the timers. Okay. If I say IP protocol, what protocol it is using? RIP protocol. What is sending updates after every 30 seconds? It's nothing but the hello timer. Next is next during 20 seconds. That is, I'll show you later. So invalid timer is what? 180 second, and hold timer is 180 second again, and flash after 240 seconds. Okay, you can see here default version where it can send the information to version 1 and receive from any version. Okay, currently it is running on the same. And what network switch are there? 192.168.1.0 and 4.0 that is directly connected. What is this gateway? It is the next hop where it is going to reach to the next networks or different network. So distance value is what? 120. Okay. So just see this last update. 25, 26, 27, 28, 29, 30, 0. That means after this it sent one hello packet to the next neighbor. Okay. Let's do one thing. Let's make this interface as down. Which one is that? 0/1, I guess. 0. Interface greater than 0/0 and make it shut down. That interface is down now. So let's go to this and just say show IP protocols. Okay, you can see here, instead of going back to the 30, it started counting from 30. Okay, but still it is reaching this 4.1. That is nothing but this router 1. You can notice both the timers. First one reset back to the 30, sorry 0. Okay, and but the second one it is still running. 180 means what? How many minutes? 3 minutes. Yeah. 240. Huh? We have to wait for 4 minutes. Okay. But let me show you the routing table here. Show IP route. Does it have any 3 network here? No. Let me show you it on the router 1. Show IP route. Is it having 3 route? Yes, it is having. But it says that it is possibly down because it is not replying for what? Hello messages. Okay. I mean, still this router 2, it is sharing the information of this router 3 to router 1, but it is not keeping it. Yes, it is not there in the router 2, but it already sent to this one. So same it will be keeping up to when it completes 240 seconds. Once the 240 seconds will be completed, this router 1 will also be removing the information of this router 3. Okay, so let's check like what is the timer here. 2 minutes 47 seconds. Still we have to wait for 1 minute. Four minutes. Let's go to first router. Let's check the routing table here. Still it is having. Wait for it. Remote. Remote, right? Yes. So after the flash timer, it will just remove the information of that 3.0 network. You can see here, it was there. 3.0 network was there. Now it is not there. Just it is having 2.0 and yeah, only 2.0 network. Because it learned two network with the help of this RIP. One is 3.0 and the 2.0. Okay. And even it removed 5.0 network also. Okay. Understood? Am I clear? Okay. Now let's go to the versions. No shutdown. Okay. So I'm going to keep the same as it is. This one I'm going to make it as a version 1. So how to change the version here? You have to say router rip again, and you need to say version. If I say question mark, it will be having 2. So I'm going to make it as a 1. Okay. And last one, I'm going to make it as what? Version 2. Okay. Let's create some loopback addresses here. I think already done. Let's do some more. Config t interface loopback 3, and the IP address will be like 3.3.3 with 255.0.0.0. Okay, that is done. Exit router rip, and the network will be 3.0.0.0. Okay, so and show IP route. There it is. Okay, this is a loopback address. Yes. So do you think that route will be there on this router 2 and as well as router 3? It's there or not? It will be there or not? Take a random guess. Yes or no? On both the routers? Sure. Okay, let us check. Show IP route. It's there? Is there? Oh, is it there? No. Why? I said like the routers which are there in the version 2, they will receive information only from the router 2. Sorry, version 2. Okay, not from the version 1 or default version. Okay, but this is into default version, this is version 1. So both can exchange the routing information. So that is the reason you can able to see the routing, route of 3.0.0.0 on router 2, because both are like same default and version 1, but this is in version 2. So that is the reason it is not exchanging any routing information with these routers like version 1 and version 2. Understood? Sorry, default version and the version 1. Yes. So this was about the versions, total RIP protocol. Isn't it very simple? What you have to do here? You just need to advertise your directly connected routes. That is it. So automatically they will learn the addresses and it will help you to make the communication with the other network. Clear? Am I clear? Okay. Timer. Only what I've done here? Hello timer. What was the hello timer initially? 30 seconds. And then then I change it to 200. And then huh? Then plus 242. So is that correct? Is that correct? What are you looking at? Basic. It has to send it up to 120 and I'll make it as I'll keep as it is 180, 180, okay, and make it as 200 plus after 200. Okay, if you want to check it, to IP protocols. There it is. Sending update after 120 second. Okay, and next is in 30 second. 36 second. Invalid after 180 and whole timer is again 180 and flush is 200 seconds. Okay, it is not going to wait for 240 seconds. It is just within 200 seconds. It's going to flush out that information. Okay, this is how to change the timers in RIP. Clear? Next, we'll see what exactly this link state protocol is. Okay. Till now, we have seen, as I already said to you, in CCNA, what I said, they don't ask you what is RIP. They're not going to ask you. Okay. They have only OSPF, not even EIGRP. Okay. But we are going to study one protocol from each types. Like distance vector protocol, we have RIP. Okay. In link state protocol, we are going to study OSPF, and that is important. And in hybrid, we are going to learn this EIGRP. Clear? And the advanced version of this OSPF and EIGRP, you are going to learn it in again CCNP. And in detailed BGP, you are going to learn it in CCNP. Okay. because BGP also it is not there in the CCNA. Clear? Now one of it like link state protocol. So here each router has a complete view of the network topology. What you are seeing in the distance protocol, they only knows their neighbor. Okay, whatever the neighbor is sending you the information, that you are keeping it in your routing table. But here in this link state protocol, it will be knowing every other neighbor who are present in the whole topology. Okay, because of what? Because of this LSA, link state advertisement. Okay, so here routers will exchange link state advertisement to share information about directly connected links. Okay, here each and every router, they are going to create their LSA, link state advertisement, and that will be sent to every other router which are present in the topology. So this is how they are going to maintain the whole network topology which they are present in. Okay, so it works on the algorithm called shortest path first, or even you can say Dijkstra algorithm, just to find what? Best path, just to calculate the best path. And here it requires more memory and processing power due to detailed topology maps. Why it need more memory and the CPU? Because it will be keeping the information of all the routes, whole topology where it is connected in. So because of that, it has to have more memory and even the processing power also. Okay, and the convergence is really quick here, like fast adaptation to the network changes, because it is not going to give you the periodic updates. Okay, it is going to give you the incremental update. What do you mean by incremental update? Whenever any topology changes, then at the same time it will be sending the same packet to, the same update to everyone. Okay, not like the RIP. What the RIP will do? After every 30 seconds, it will changes. Even though there is no any change in the topology, it will do that. But in this one, link state, okay, it will do only when the topology changes happens. Okay, that is the reason the convergence time is really fast here. Okay, and it minimizes the unnecessary traffic after initial LSA flooding. Initial LSA flooding means what? First, whenever they will be connected in the topology, okay. As I said, they will create their LSA database and they will send it to everyone. Everyone, whatever the routers which are connected in. Okay, and that is it. That is called as what? LSA flooding. And this LSA flooding will be happening initially just to maintain their 3 tables. It maintains 3 tables. Link state protocols maintains 3 tables. What are those? First one is a neighbor table, and second one topology table, and third one it is a actual routing table. So these are the 3 tables this maintains. Okay, and just to maintain these 3 tables, the initial LSA flooding will takes place. Okay, after that it will not exchange any kind of routing table, just like the RIP. Okay, yes, they will say hello to each other for every after 60 seconds, I guess. Okay, but at that time it is not going to share the routing table, but it will just check the connectivity. You are my neighbor, are you alive or not? If you're not alive, let me check the different path to reach the destination. Okay, for that they will exchange what? The hello messages, not the actual routing table. Clear? So here we have some 2 types. One is what? Open shortest path first. In short, we call it as the OSPF. And second is the ISIS, intermediate system to intermediate system. Okay. So out of these 2, we are going to learn only this OSPF. And this is really important as for your CCNA examination. Okay. Clear? So tomorrow we are going to start with the OSPF. That is a big protocol. Okay. So a lot of things we have here. So total class, we are going to cover this one protocol, OSPF. Okay, understood? Great. Okay, then we'll finish it today. Yes.
Thank you.
Yeah.